Hello everyone, in this video, Dr. John wants to introduce a more sophisticated and a complicated linear the problem that you can use linear program to solving that. So in the first case, we're going to look at is related to the investment. So in finance, linear programming can be applied in problem solution involving capital budgeting, make or buy decision, asset allocation, portfolio selection, financial planning, and many more. So in this special case, we focus on portfolio selection problem. So portfolio selection problem involves situation in which a financial manager must select a specific investment, for example, stocks and bonds, for a variety of investment alternatives. Managers of the mutual fund, credit union, insurance company, and the bankers frequently encounter this type of problem. The objective function, okay, as you're reading here, you know that we are talking about object function. For portfolio selection problem, usually is maximize of expected return or minimization of the risk. The constraint usually take the form of restriction on the type of the permissible investment, state laws, company policy, maximum permission risk, and so on. So problems of this type have been formulated and solved using a variety of optimization technique. In this section, we formulate and solve the portfolio selection problem as a linear program. Consider the case of the mutual fund located in New York City. Just obtained $100,000 by converting industrial bond to cash and is now looking for other investment opportunity for their funds. Based on the wealth of current investment, the firm top financial analysts recommend that all new investment be made in the oil industry, steel industry, or government bond. So they have some, of course, as reading here, you understand that they have limitation on the industry they want to invest. Especially, the analysts identify 5 investment opportunities and project their annual rate of return. The investment and the rate of return are below in the table. As you can see, the 5 investment opportunity including Atlantic Oil, Pacific Oil, Midwest Steel, Hoover Steel, and government bonds. So the first 4 are related to energy, the last one related to the government bond, and it does a crossing oil, steel, and government, oil and the steel industry and the government bond. Okay. So on the second column in this table is the return. So basically the project return is if you put $100 in Atlantic Oil, so you expect to get $7.3, okay, for a year. So this is projected return, and so they'll measure under the percentage. Okay, when you set up optimization problems, you do not need to converting 7.3 to 0.07.3. You just need to make sure you consistently using the same measurement unit. So if when you're creating your formulate your objective function, you did not including the percentage sign. You basically use 7.3, 10.3. You have to understand at the end, the Excel solver solving to you the value itself is the value, and then you're going to add a percentage when you interpret it. Okay, so we understand the return of each stock, and now we're going to look at the constraint. So the management and the wealth impose the following investment guidelines. Neither industrial, oil or steel should receive more than $50,000. So basically, all the investment in either oil or steel has to be smaller and equal to $50,000. Right? Neither, right? So none of them should receive more than that. So everything has to be smaller and equal to 50,000. So the amount invested in government bonds should be at least 25% of the steel industry investment. So basically, the amount you put in the government bond has to be at least, so it has to be larger and equal to 20%, 25% the steel industry investment. So the investment in Pacific Oil, the high return but a high risk investment cannot be more than 60% total oil industry investment. So here we have 3 constraints, and we also have one more, right? What portfolio recommendation investment and amount should be made for the available $100,000? Okay, so the goal here, although it didn't directly talking about there is a constraint, but actually it is a constraint. So being an investor, you don't want to left out any money. Also, you don't want to over-invest since you don't have that much fund. So basically, this $100,000 means if you add all your investment together, it should equal to $100,000. Okay, so let's put everything in written so that we can formalize our problem. Okay, let me open a blank Word document and I will start typing the answers. Okay, so first of all, what are my decision variables, right? Or choice variable? These decision variables. Like I said, we can either using the short form. So for instance, for the Atlantic oil, you can say A Atlantic oil, or the other way. In this chapter, we're also talking about more general expression. Use x1, x2, x3, x4. So totally okay with me. So here, since in the previous computer skill lecture, I used the symbolic short, the acronym, but now I want to use more general way x1, x2, x3 because after this case, we're going to look at more complicated cases. So sometimes you should get familiar with a more general term. So let's see, x1 will represent to the dollar invest in at Atlantic oil, and the x2 is the dollar invested in Pacific oil, and x3 is the dollar invested in Midwest steel, and the x4 is the dollar invested in Hoover steel, and the x5 is the dollar invested in government bond. Okay, so those are my decision variables as you go back to look at the case. So those are the 5 opportunity we have here. And I didn't directly call Atlantic oil because the question here is how do we want to allocating the money to invest in each one of them. Therefore, the decision variable here is the money dollar value investing in each one of the opportunities. So my objective function is trying to maximize the portfolio return, right? The return. And then we're going to learn how we can expressing the return. So if the x1 is the amount of money we put in Atlantic oil, so the return for that specific asset would be 7.3 x1, right? X1 is the total money put in it times the percentage return will give you the return. And similarly, the other one is Pacific oil, and so you are using the return 10.3. Again, so it is under the percentage. It really depends on what you are interpreting. So you can either convert it to the percentage or directly using it, but you need to make sure you consistently understand the number you put in it. So for me personally, I do like a convert to the actual value when I put in my formulas. And so because that's how I initially want to understand, because if I using x times 7.3 and I'm exaggerating the return, right? The return is 0.073. Okay, so I will start to typing my answer here. So the return I will get from Atlantic oil is equal to the return, which is 0.073 times x1 plus the return for the Pacific oil is 10.3%, so it will be 0.103 x2 and the plus times x2 and the plus the next one is 6.4%, so it will be 0.464 times x3 plus 0.0475 times x4 and then plus 0.45 times x5. Okay, so we have totally the following representing the return of this whole portfolio I plan to invest. So this is my objective function, okay? My decision variable, my objective function. Now I'm going to start to list my constraints. So as I said, we will have several constraints, but the first constraint is we have $100,000. We need to make sure we use all $100,000. So therefore, the investment x1 plus x2 plus x3 plus x4 plus x5 has to equal to 100,000, right? So this is the spending total money I have. So this is total money we have here. Okay, so the next constraint is related to, we're going to start translate, right? So the neither industry oil should receive more than $50,000. So all either oil or steel has to be less than 50,000. So let's go back. So for the oil, we have two stock related to oil. So basically these two stocks investment add together should less than 50,000. And then these two are related to steel. So these two add together has to smaller than $50,000. So therefore, we can say is the oil constraint. So this is equal to x1 plus x2 has to smaller and equal to $50,000. And the steel constraint, this is x3 plus x4 also smaller equal to $50,000. Okay, so this is the two constraint related to this. The management has certain requirement, and then that's going on next. The amount investment in government bonds should at least 25% of the steel industry investment. So therefore, the bond, the X5 here has to be larger and equal to the what is that? A steel industry investment. So steel industry is X3 and X4, right? So basically X5 has to be larger and equal to 25% of the X3 plus X4. So basically we're translating what we've seen in this sentence to the mathematical expression here. So this is government bond constraint. So this has to be government bond is X5 has to be larger, equal to 25% would be 0.25 times the 25, at least 25% of the steel industry, so X3 plus X4. Okay, so this is the government bond constraint has to be larger than no smaller than 25%. Okay, so the last constraint, the investment in Pacific Oil, the high return, so basically the high return 10.3%, this one cannot be more than 60% of the total oil industry investment. So therefore, the Pacific oil, this is X2, has to be smaller and equal to the both of them adding together 60%. 60% of both of them add together. Okay, so therefore we can translate to Pacific oil constraint. So for this one is related to X2 has to be smaller and equal to 0.60%, right, of the X1 plus X2. Okay. Okay, after that, of course, we have non-negativity constraint, right? So X non-negativity constraint, because you cannot invest the negative amount of money, right? So X1, X2, X3, X4, X5, they all has to be larger than or equal to 0. Perfect. So now I set up my constraints, everything is ready. Now what I'm gonna do in next video is we're gonna put everything onto the Excel and we use solver to solving the problem.